Lesson 113, More Real-World Problems. For this task, we've been given a diagram that has some measurements, and we're being asked to find the perimeters of the inside and outside rectangles. The perimeters, of course, to calculate perimeter of a rectangle, of course, we're talking about finding the total length of all four sides. Usually when I see perimeter questions involving rectangles, this point to this point is considered the length, and this point to this point is considered the width. For whatever reason, those labels have been switched in this example. In other words, this is being considered the length of the outside rectangle, and this measurement from here to here is being considered the width. Notice for that outside rectangle, the length has been given to us. The width has not, but we can calculate the width with the clues of some of the other measurements that are shown in this diagram. If we're trying to figure this measurement from here to here, we can add up 3/4 plus 2.5 plus 1/4. That will give us the width of the outside rectangle. Now looking at the inside rectangle, the width has been given to us, the measurement from this point to this point. The length is not. So for the inside rectangle, if I'm trying to solve for L, which would represent the measurement from here to here, I can think about this in terms of adding first. In other words, this measurement plus the 1/2 inch up top plus the 1/4 inch at the bottom all together is going to equal this amount, 3 3/4. So I can express that a different way. I can say, well, this can be found by taking this bigger amount and subtracting out a 1/2 and a 1/4. And what is left is going to be this length from here to here. Why don't we go ahead and do our calculations for the outside rectangle first? And I have actually done this work already. Let me talk you through it. The length, as we said, has been given to us, 3 3/4. The width we need to calculate. We do that by taking the 3/4 plus the 2.5 plus the 1/4. Boom, boom, boom. I need a common denominator here, and 4 is a good choice. I'll simply rewrite 2.5 as 2 2/4. Now my denominators match. When I'm adding these three up, in this case, I notice that, well, 3/4 plus a 1/4, I can combine those to make one whole, and then I can add that whole on the 2 2/4 to get 3 2/4, and reduce that fraction to show it as 3.5. My width of the outside rectangle is therefore 3.5 inches. Now, let's add it all up to find the perimeter of the outside rectangle. 3 3/4 plus 3 3/4 plus 3.5 plus 3.5. Well, I use the 4 again as the common denominator and express 3.5 in both these cases here as 3 2/4. Added up my whole numbers first. 3, 3, 3, 3 got me 12. Added up the fractions. 3/4 plus 3/4 plus 2/4 plus 2/4 got me 10/4. Improper. 10/4 was improper. So that on its own, I needed to clean up and regroup and convert into 2 2/4. Combine that with whole number 12 to get 14 2/4. And my final answer can be reduced. The fraction can be shown as a 1/2, 14.5 inches. Now, let's take a look at the inside rectangle. In this case, the width has been given to us, but we need to calculate the length. We're going to calculate the length by taking this larger measurement, point to point, 3 3/4, minus a 1/2, minus 1/4. What we get, or what will be left over, is going to be the length that we are needing to solve for. So 3 3/4 minus a half minus a fourth. Let's use 4 as the common denominator, and we'll show a half as 2/4. 3 3/4 minus 2/4 minus 1/4. Our length is 3 inches. Our width, as we said, has already been given to us, 2.5 inches. Let's put that all together. 3 plus 3 plus 2.5 plus 2.5. Let's do whole numbers first. 3 and 3 is 6, and 2 is 8, and 2 is 10. Our fractions, a half plus a half is a whole. 2/2 are a whole. Maybe I'll write it that way. Yeah, that's what erasers are for, right? 10 and 2/2. Show that as 11 inches.